last term here because they're mutually exclusive, right? So probably P and Q drops to 0. I'm using a special case here. Because I said in the assumptions, these events are independent. So these events are mutually exclusive and exhaustive with each other. This value must equal 1. Does that make sense? Shorthanding that, given what I showed there, P plus Q equals 1. Right? I'm not going to have nested probability of P, probability of Q. It's going to be P and Q. All right? P is typically listed as a success, Q is listed as a failure. If, let me get rid of stuff in the middle. If I have n equal to 1, one trial, right? Say I flip a coin, right? How many possible outcomes are there flipping a coin? 2. What are they? Heads or tails. So if I have a coin, I get either heads or tails, which I could then set up just like over there, P or Q, right? Probability of heads. Probability of heads. 50-50, not 50, but 50%, 0.50. So that's going to equal to 0.5 plus 0.5, which equals 1. Right?
And then would you fluctuate that, just depending on your numbers?
What do you mean fluctuate that? What is that?
Like maybe heads might be like 0.6 and.
With a coin, heads are never 0.6 and 0.4. We're assuming fair coins throughout here. If I say I've got a biased coin, I might put in a coin that has a 60% chance of getting heads and a 40% chance of getting tails, but that is a biased coin and would be an unfair coin.
Okay, so that doesn't apply.
Does not apply. Overwhelmingly, when we're talking about coins, we're talking about dice, we're going to assume they are fair, they are unbiased. You go with the a priori calculations for those outcomes. You should recognize what a priori means compared to a posteriori.
It's Latin.
Indeed.
Bonjour.
That's not loud.
Pri means before, post is after.
Yes.
Thanks to the English people.
All right. Notice. Oops. If I flip a coin twice,
Uh-oh.
right? I flip a coin twice. That means I flip the coin, look at the result, and is important because that's going to go right here. Right? I flip the coin the second time. Probability of flipping the coin is, right, I get P, well, let's do heads and tails first and I'll do P and Q. I get heads or tails on the first flip times heads or tails on the second flip. Right? Which essentially P plus Q times P plus Q. First flip, heads or tails, or plus second flip, heads or tails, first and second is multiplication. Right? Notice that. Well, so wait. How many possible specific outcomes are there if I flip a coin twice?
4.
Do you know what they are?
Heads or tails, heads or tails.
No.
Oh, what do you
All
mean?
the specific outcomes.
So heads, heads, tails, tails, heads, tails, tails, heads.
Correct. There are 4 outcomes. I can either get heads followed by heads, right? Tails followed by tails, or I might flip heads on the first coin, tails on the second coin, or tails on the first coin and heads on the second coin. Right? Those are only 4 possibilities. Right?
So it's kind of like using like a Punnett square when you
No, I wouldn't say that. In the one sense that you're filling out all the possibilities, yes, but I would not confuse this with Punnett squares at all. That would be an entirely different thing. Does that make sense? All right. Notice, if I say, what's the probability of getting heads and heads, right, on the first thing, right? That's 0.50 times 0.50, which gives me, in this case, 0.25. Probably getting tails and tails, so tails followed by tails on 2 flips, is 0.25. What's the probability I get a single head in 2 flips? The head could come first, the head could come second, right? These 2 combined, because they're both 1 head and 2 flips, is 0.50. Right? If I were to draw that in terms of probability distribution, 0 heads. Notice 0 heads is the same thing as 2 tails. Or I can have 1 head, which is the same thing as 1 tail. Or I can have 2 heads, which is the same thing as 0 tails. Put a slash through those to make them zeros instead of 0.25, 0.50, 0.25. That make sense? I'm just graphically representing the same probabilities I calculated there coming from this data. Right? It's also worth noting, if I take these two parenthetical statements and actually multiply them across, right? So I expand that to polynomial. I get that variation of the equation. Right? P times P is P squared. P times Q is the same thing as P cubed, but there are 2 ways to do that because I get 1 head, 1 tail, or 1 tail, 1 head. So the coefficient in front of that 2 here represents the number of ways I can do it, right? Q squared is the same thing as 2 tails, right? Does that make sense?
No.
No?
Yes. Wait.
This is equivalent
I won't lie.
to the heads, heads. This is equivalent to heads, tails, or tails, heads. This is equivalent to tails, tails,
Okay.
right? Which is the same thing I just drew over there.
I see.
Gotcha.
I remember some of this somewhat.
I doubt it. I doubt you've ever come across this before.
Years ago.
He
and I'm
was
trying
funny. I just.
I cannot think of a context where this would be taught in high school level or earlier.
Binomial distributions, they were taught in high school. Not this exactly, but we learned about binomial
So,
distributions.
but I think,
No, you probably are referencing bimodal distribution.
No,
hang on.
I'm not.
Okay, I'll take your word for it.
She just got out of school. She knows.
I was
All right.
trying to remember.
You okay with this presentation? I'm going to simplify this briefly. I'm going to take off the heads and tails.
I can't remember.
I'm going to move this around. Right? When n equals 2,
I'm mutually.
that's essentially. Let me redraw the top one here too.
No,
When n equals 1, P plus Q equals
Like right here where you put
1.
The foil.
When n is 2, that's P plus Q times P plus Q. Oh, you're talking about FOIL method. Yeah, this is FOIL method.
He
You're
just.
talking first, outer, inner, last.
Foil.
This is still FOIL.
Yes.
Foil.
That's
Oh
FOIL
my
is not binomial. FOIL is a method of multiplying polynomial statements,
Darn it!
but it's not binomial.
But
Well,
she was on to
But yes,
something.
because it's a polynomial statement, you can multiply using the FOIL method.
Good job.
Fool. Sorry.
But for the most examples, right, while it can be expanded and will be expanded, yeah, this is where that idea is going to pretty much stop because it gets same idea, but instead of being first, outer, inner, last, it'll
That
be
was
first,
the
and
last
outer,
one,
and
this
inner, and
was
second,
that
and
one.
outer, and inner, and third, and outer, and it'll be a bunch of them.
First, outer, ear, last.
Girl, what is that? Where you get that? Oh, that's
So there are 2 common ways. This is the second expansion for the binomial. This is the first expansion, this is the second expansion. Right, the way to think of this is, you flip a coin once, there are 2 outcomes. Flip a coin once, there are 2 outcomes. You flip a coin twice. Second flip, first flip, second flip. On each flip, there are 2 outcomes. Right? When you combine it mathematically, there are 3 possibilities when you're looking at number of successes compared to number of trials. Number of heads can be either 0 heads, which means you failed twice, 2 tails. Number of heads can be 1 head, in which case you got 1 failure, 1 and 1. 2 ways to do it. Heads, tails, tails, heads. Right? 2 tails, 2 failures, 0 heads. Right? So the probability of 0.25, 0.50, 0.25. You add those up, 1. Okay? Watch my time. Then I go to n equals 3. If I flip the coin 3 times, right, I get heads, tails on the first flip, heads or tails on the second flip, heads or tails on the third flip. So n equals 3, P plus Q times P plus Q times P plus Q, or if you want, P plus Q to the 3rd power. This would be P plus Q squared, right? If I multiply out here, and this is where you kind of lose FOIL. Technically, you're still using FOIL, but if I multiply across, I'm going to have multiple things. It's not going to be as simple as this one. I'm going to end up with, when I multiply across all 3 parenthetical statements, P cubed plus 3 P squared Q plus 3 PQ squared plus Q cubed. Alright? You're still basically using FOIL,
Yeah.
but you're using FOIL for the first pair, and once you get the solution, multiplying the total solution by the second
Okay.
parenthetical statement. Or I should say third parenthetical statement. Does that make sense? If I add up P cubed plus 3P squared cubed plus 3PQ squared plus Q cubed, what do I get?
1.
1. Probability must be 1. Now, in terms of the outcomes, if these were the outcomes for n equals 2, right, how many possible ways are there for n equals 3? How many possible total outcomes are there?
6.
Close. No.
8.
Are you guessing?
No, I thought 6, but now I'm guessing.
It is in fact 8. I can have heads, 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 right? What's the probability of getting 3 heads in a row? What's probably getting a heads and a heads and a heads? Conceptually, using the addition rule over here.
What?
What's probably getting 1 head on the first flip?
50.
0.50. What's probably getting a head on the second flip?
0.5.
What's probably getting a head on the third flip?
0.5.
And so if I'm getting first flip and second flip and third flip,
I don't know.
1.5 after 3. So, yeah.
not 1, but
But
it's 0.5 to the third power,
Oh.
right? So 0.5 times 0.5 times 0.5, which is 0.125,
Okay.
right? Or, well, put it this way, 5.5 to the third power, right?
Okay.
That's this value. P to the third means I've got 3 successes, right? Heads, 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 right? Then I go to this one, this term, I'll underline it. Get rid of my decimal. 3 times P squared Q, right? If P represents the heads and Q represents the tails, that means I get 2 heads and 1 tail. It's got squared is 2 heads, right? Q has no exponent. Technically, it's an exponent of 1. Come back to that in a minute, right? So this is essentially heads, heads, tails, but there are 3 ways to do that. I can go heads, heads, tails, or I can have heads, tails, heads, or I can have tails, heads, heads. Right? All 3 of those combined are the equivalent of, let's put it this way. First one, 3 successes. This one, 2 successes. Right? What's the probability of each one individually?
0.125.
0.125, but there are 3 of them. Probability of one of those 3 is 0.375. 0.125 plus 0.125 plus 0.125. Right? This term now is 1 head, that's the P, 2 Q's. Right? If you want to think, P times Q, because Q squared is Q times Q. Right? And so this then becomes, we get rid of the one underneath here, run on the page. That becomes heads, tails, tails, or if you want tails, heads, tails, or if you want tails, tails, heads. And again, 0.375. 1 success, so I'm calling a success being a head. And there's only 1 head in each of those cases. So far, so good. Last term, Q to the third, right? Q represents a failure. Q to the third is Q times Q times Q. Right? Q in this context is a failure, it's tail. And that means tails, 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 3 tails, which is the same as 3 heads, which is 0.125, which is 0 successes, right? 3 failures. If I have 3 successes, I have 0 failures. If I have 2 successes, I have 1 failure. If I have 1 success, I have 2 failures. Because I did it 3 times. If I have 0 success, I may have 3 failures. With me so far?
And what are we supposed to be learning exactly?
We're gonna keep,
Good.
we're gonna keep doing this for a minute, and then we're all gonna tie together the probabilities.
So what is those?
I'm
the probability
I'm building
of being
this
successful.
for the idea of it, and then we're gonna give you some ways to interpret it once I get.
Are we getting homework tonight?
Yes.
Okay. Great.
All right. Everybody okay with the 3 presentations? Notice there are 8 total possibilities. I get Heads, 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 tails, heads, tails, heads, tails, head, 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 tail, 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 head, head, tail, head, tail, 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 head, tail, tail, tail. There are 8 ways to do it. Right? Flip the coin 3 times. You don't have to memorize this. You don't need to memorize this at all.
I think there
This is-
ain't no way
build.
possible for me to remember that.
Using classical
Off the top of my head.
conditioning.
For you, but for me,
Electrocute us every time we
All
get
right.
it wrong.
I struggle with memory. I'm getting old.
And then go over here.
He's very old.
I'm about the same age as him.
Probably any number of trials is now 4.
Okay.
Right? That means if I'm doing something over and over again, individual trials 4 times,
It's not hard.
on each individual trial, there are 2 outcomes. So there's the first, there's the second, there's the third, there's the fourth. Or if you want, P plus Q to the 4th power. Right? Just add it, 1 more trial. I flipped the coin the 4th time, where originally, here's the first 3. Right? There's 3 flips, I added a 4th flip. So this part of the equation is already done here. Right?
Right.
If I go ahead and expand this to the complete polynomial, oops, let me do it this way. Q plus 6p squared, q squared plus 4p, q plus q to the 4th. That's 4, n equals 4. Right?
Okay.
Hang on. Notice this represents, if I have p to the 4th, how many successes in 4 trials do I have?
4.
I got 4 successes, right? P represents a success. P times P times P times P is essentially heads, 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 right? Make sense? Which is going to be equal to, essentially, 0.0625, right? Well, if I were to draw the previous one, if I draw the third one, the distribution looks like this. Where this was the 125, this is the 0.375, this is the 0.375, this is the 125, right? So this one's n equals 3. N equals 3, I can have 3 successes, 1 success, 2 successes, 0 successes. Sorry. 3, 2, 1, 0. Right? If I have 4 heads in a row, how many tails did I get?
0.
0. On the other hand, if I have 3 heads, notice the exponent here. The exponent represents the number of times this thing occurs in 4 trials. If I have 3 heads, how many tails?
1,
1. How many ways are there to do that?
4,
Huh?
4.
There are 4 ways to do that. That's represented by the coefficient here, right? I can have heads, 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 tails, heads, heads, tails, heads, heads, tails, heads, heads, tails, heads, heads, heads. 4 ways to do that. That is all represented by that term,
Okay.
right?
Now we're gonna have to have all that wrote down one time.
No. I'm gonna give you
Okay, that is
I'm gonna
a
give you individual
whole
expansions.
lot, and I'm about to take a nap after this class.
I'm gonna give you the individual expansion. I'll tell you I'll tell you what I'm gonna give you as the formulas in a little bit.
Yeah, that's fine.
Right.
Oh, I'm getting ready to be knocked out. I'm taking a shower and going straight to bed.
Have to work tonight.
All right.
Not me, I'm not doing that.
Middle term here, right? P squared, Q squared. How many heads, how many tails?
2,
2 each, right? 2 heads, 2 tails. How many ways to do that?
6.
6, which is what the coefficient represents, right? So I have 2 heads, 2 tails I can have. Heads, heads, tails, tails. I can have heads,
I'm about to throw it.
tails, heads, tails. I can have tails, tails, heads, heads. I can have tails, heads, tails, heads. I can have tails, heads, heads, tails. I can have heads, tails, tails, heads. That's the 6 ways to do it.
Oh man, no either.
You will not have to generate those heads and tails. You may.
Oh my god, it's like doing Bitcoin or something. Generating Bitcoins and stuff for the miner. I can't help it. I can't do it. The mining stuff. All this mining.
Alright. Here's the point I'll carry this one around a little place on the board. Look at the exponents, look at the coefficients. The exponents represent how many successes or failures in this number of trials. Right? So the number of successes and the number of failures must sum to the number of trials. Okay? While it's not written typically in equations, if I have something like, and I'll write it out more specifically, bring this down a little bit. 4p cubed q. Technically, that is 4p cubed q1. Q to the first power. Q to the first power is itself. Right?
So that's one tail? No.
This is 3 heads, 1 tail. That's what I just
That's,
erased a minute.
that's what I said, okay.
3 heads, 1 tail. But because any value to the first power is itself,
Exactly,
it's usually it's not listed, it's typically it's dropped off. Right?
gotcha.
On the other hand, I have something like, let's say p to the 0 q, well, in this case to the 4th, right?
So you got
What is
four-
anything to the 0 power?
Nothing, it's
Zero.
zero.
Not 0.
It's nothing, it's,
Negative 1.
It's 1.
it's,
Anything to the 0 power is equal to 1. Which basically means this term, the q to the 4th, is the same thing as p to the 0, q to the 4th. P to the 0 is equal to 1 times q to the 4th, which is q to the 4th. Right? Over here, this term, p to the 4th, that's technically p to the 4th, q to the 0. 4 successes, 0 failures. Right? That drops off is equal to 1.
oh, because multiplied by one is whatever the answer is.
Anything multiplied by 1
4
is the
times
same
one
thing.
is one.
Anything multiplied by 1 is the number
Can
we
we
started.
keep the cube though?
Huh?
Can we keep cube, like, just don't even worry, like, just keep it, yeah,
Can you
keep.
just, yeah, but can you just not give us any 0 exponents, please?
I'm going to leave it as the written equation here.
On the text too,
I'm going to give you this kind of equation.
on the text too, right?
Yeah, I'm going to give you this equation on the
Okay.
test. Now, I'm not going to do this. It's getting repetitive, right? P plus q, parentheses, times p plus q times.
You're
Assume
gonna
that's
use
5
the
times now, so
expand.
p plus q to the 5th power.
Okay.
That's then going to set up in this form, the full expansion, as p to the 5th plus 5p4q plus, let's see, what's my coefficient on my third term? I think I guess. Don't guess.
Is it 4? Is it? Wait.
I would say
I actually don't know.
7.
Huh?
I would say 7. Oh, it's close. It's only a 10 off. Why would it be 10?
I'll tell you in a second.
Yeah, I don't know.
So there's the full expansion with trials equal to 5. Right? First term, p to the 5th, 5 successes and 5 trials.
Wait, can you let us finish writing first? Because that's where I get lost at
Okay.
trying to write while you talk.
Tell me when to let go.
Thank you.
Oh, that's so funny.
So, Nathaniel.
Okay, go.
I'm good.
Notice this is n equals 5. I'm flipping a coin 5 times. Right? In those 5 flips, if I get 5 heads in a row, that's 5 successes, that's the exponent p to the 5th. This is 5 heads means I get 0 tails, q to the 0, but that's not represented because q is equal to 1.
Mm-hmm.
4 heads, 1 tail, q to the 1st, 5 ways to do it.
Mm-hmm.
Right? 3 heads, 2 tails, 3, 2 is the exponents, 10 ways to do it.
Okay.
Right? 2 heads, 3 tails, 10 ways to do it. 1 head, 4 tails, 5 ways to do it. 5 tails, 0 heads, 1 way to do it. All tails.
Okay, this makes so much sense.
Right? Cool. Then you gotta tell me the next one. What's the exponent?
6.
6. Right? 6 trials, 6 heads. Good enough. Right? If I have 5 successes,
It's
1
about
failure,
6.
how many ways to do that?
6.
There are in fact 6. That is in fact the pattern. But next is probably a little more difficult for you.
Yeah, I don't know that one.
4 successes. If I have 4 successes, what's the exponent here?
So if that was 5, would it be 10? Would it be
2.
20?
2.
Right? In any
Oh,
given
okay.
any given little piece of this, the 2 exponents must sum to n. Right? So over here, 6 plus 0 is 6, 5 plus 1 is 6, 4 plus 2 is 6.
Okay.
Right? So what's the coefficient in front of this one?
I have no.
25?
12?
How many ways are there to do it?
Is it 64? Yeah. Am I tripping? 32.
No,
Dude, I don't know what I'm
Maybe
doing here. I'm
16.
done talking.
I thought he was.
15.
What?
Where did
That doesn't
Ah,
make sense.
that's
it will make sense in a minute.
Whatever.
Because it's 2, and then if that was 10, because it was 5 ways.
I'm going to give you this
10,
one.
20. Okay, what the heck?
15, P4, Q2.
Now,
Dang, 20.
How many trials are we gonna go up to?
Probably 7, maybe 8.
Lee.
Technically, as many as you want. We looked at n equals 20.
Yes.
Right.
I don't want to.
What's my last term here? Let's go here.
Q to the 6. Oh,
That's okay. We'll do it that way.
I'm sorry.
I was going to call something else. Q to the 6 is my last term. Something important here to note if you haven't noted it already. Right? Small little kind of check. Right? There are a number of terms in any given sequence which is always one higher than the number of n. So if n is equal to 6, there's 1, 2, 3, 4, 5, 6, 7 terms in the equation. If n is equal to 5, there are 6 terms in the equation. Right? The exponents represent the number of successes and failures. So the exponent is p is the number of successes. Exponent of q is the number of failures. The coefficient in front of it is the number of ways you can rotate it in terms of the combinations to produce that particular number of successes and failures. Right?
Can you pass the test without doing this page?
You'll be able to do this relatively easy. I'm going to simplify this massively for you in a couple ways here a bit. So here, let's do one more and then we'll take a break. So n equals 7. Go around the room here. What's my first term, Peter? What's my p first term here? Not 7. P to the 7th. Number of successes to the 7th. You may get a pattern. What's my next number? Going on.
Me?
Yeah.
7?
7 is my coefficient. Times p to the what? 6. Q to the what?
1.
I see that? Next one I don't expect you to know. I will simply come on. Does anybody know what the coefficient is going to be in front of this term?
no.
20? No, I'm sure.
Close.
25.
It's gonna
21.
It's
Oh
impossible.
my
I think it's
gosh.
impossible.
There's in fact a very, very precise mathematical pattern. I'll show you at least 2 different ways to get it that are independent of each other, by the way. So that's going to be p to the 5th, q squared. Right? Next number in terms of my coefficients, 35. P to the 4th, q cubed, plus 35. P to the 3rd, q to the 4th, plus 21. P squared, q to the 5th, plus 7, p q to the 6th, plus q to the 7th.
Holy crap.
Is it the first 2 coefficients and the one before? Like 6 and 15, 21, and then 15, 20?
Yes.
25, 25.
Yeah, actually. Let's draw that for you, then we'll take a break. See, this is actually I'll give you an answer. If I start off with this value, p plus q, if I look at the coefficients, technically the coefficients are both 1 in front of that. 1 times p is equal to p. 1 times q is equal to q. Right? So technically these have a coefficient of 1 in front of them, just like this one has this one has a coefficient of 1 in front of it. Right? There's a I said. There's only one way to get 2 heads in 2 flips. There's only one way, so first coefficient, that's a 1 in front of that, to get 3 heads in 3 flips. Right? So if I start off with, let's just say 1 and 1. Right? That's this one. I go to my n equals 2. 1, 2, 1. This is values here, here, here. Coefficients in front of each of those terms. 1, 2, 1. We go to the third one. Right? 1, 3, 3, 1. Right? So go to the fourth one. 1, 4, 6, 4, 1. Right? Now start looking at the pattern. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1, 5, because 1 plus 4 is 5. 10, 4 plus 6 is 10. 6 plus 4 is 10. 5, 1. Right? So if I go then to the sixth one, 1, 6, 15, 20, 15, 6, 1. Go to the next one, which is the last one I have there. 1, 7, 21, 35, 35, 21, 7, 1. Right? Do I see that pattern? That's the pattern you're picking up on, right?
Yep.
You keep building, that'll go on forever, right? If you don't know already, I'm not gonna hold you from knowing this class. That's called Pascal's triangle.
That's
I've
interesting.
heard of that.
Blaise Pascal is the first individual to come with that particular notation.
That's pretty interesting.
There's a more efficient mathematical way to do it that we'll do after the break. So we'll take a break this second. But that's how you create, instead of building it, so if I ask you what's the third coefficient in a series of 12 trials, right? If I say what's the third coefficient, instead of building it all the way to that point, you actually calculate it straight on. Take a break at this point. Come back in, we'll do more binomial